before I start getting to OGR, I would like to cover some of the geospatial file formats. So one of the most important parts about them is the simple feature standard, which describes how to write down geospatial data. So you would have like points, like line strings, like polygons, and all these are standardized. And this is going to be important for the next file formats, most of them. So one common one which you see often online is the GeoJSON, which is basically just a JSON file with some additional attributes. And let me check. Yeah. So and you have an additional geometry column, let's say. So you have the properties and you have the geometry. Basically, all the data we will cover here is that you have a column or an attribute, which is the geometry, and then you have additional attributes like title, name, whatever you want. Another popular file format, which is not directly related for this talk, but which you'll see also often online, is the TopoJSON, which is used for D3. This is a data visualization library for JavaScript, and it's fairly popular. That's why I thought I listed two. Another one, which is probably the most known, the most used, but the most dreaded file format is the Esri shapefile. It's basically a mess. So you have like you have 4 files. Every time you work with files, you want them to have one file for the whole thing. You don't want to have 4 different files which all do something different and are differently stored. So this is basically just a small file which I converted to a shapefile, and you see here you have already 4 files and you have no idea what they do. So just to get quickly over them, so you have the shape SHP file, which is the feature geometry. Then you have the SHX file, which is the index format. Then you have a DBF file for the attributes. And then you have a projection if you use a projection. So this is an optional. And then you have like a whole slew of others. An alternative which I find pretty good is the so-called GeoPackage and the spatial light format. Both formats are based on the SQLite, so there are basically databases which are stored in your file system. So you have one file and it's the whole database, so everything is inside. The geometry column there is a well-known binary, and the difference is that spatial lights require some additional libraries to be used, and it also offers some additional functionality. Another one which I won't cover here, but the next speaker will cover, is the PostGIS, which is a database, a real one. So one format I wanted to show, because it's basically linked, it came from linked data, is the geography markup language. So it's a XML-based language format, which is based on the resource description framework. So it came from the linked data world, and it took the OGC, the Open, what is it called, Open Geospatial Consortium. They standardized this format, and then the Keyhole markup language, which is used for the Google Earth. This one took this format and added some styling to it. So this is how it looks like. It's the common XML mess which you would usually see. And then another one which you often see if you use like a GPS tracking device on your phone or your smartwatch, which is used for describing waypoints, tracks, and routes. It's also an XML format, and it's also fairly common to see around. You also can store geospatial data in a CSV. Basically, just have another column for the longitude, longitude, or you have a well-known text part to the file. Yes. So let's go to the OGR. What is it? It's basically, like Hannah said before, it's the extension for vector data. So it's part of GDAL and it supports the majority of geospatial file formats. So, and you have basically three things, which I'll show here, is the OGR info. It's where you can get some information. It's similar to GDAL info. Then you have OGR to OGR. It's a command line tool to convert geospatial data. And then finally, I'll show you some Python bindings as well. So if you do OGR info, you get like this little information. If you want to see the different formats that are there, you can do that with formats again. Just a quick note, so the exclamation mark is only used for Jupyter. It's only to be, so you can execute code in, bash code in Jupyter. Okay, so for example, if you want to have a file, if you want to analyze what is in the file, you can do a SQL query. So you can say, okay, select everything from chapters. So I have a file called chapters. It's a JSON file. So it's over here. And I want to get all the data shown by the program. So this is basically all you get. The similar like you saw before with GDAL. And you can do other queries, like you can do the count of all the features that you have. Then you will get, like in this case, 111 features. Then you can get like a single feature. So in this case, we want all chapters where title is Maptime Salzburg. So you will get here the information for that. And the Swiss Army knife of geospatial science, in my opinion, is the OGR to OGR. It's an intensely powerful tool. You can use it for almost any conversion that you can imagine. You can do databases with it, so you can do a whole lot with it. The basic is just you have the OGR to OGR, the dash F for format, and input output, and then you have like a whole lot of other options that you can also use. So you can do all different kinds of formats with the dash F. And for example, if you want to convert a GeoJSON to GeoPackage, you would have this simple command. So as we saw before, that's dash F for GeoPackage, then the output GeoPackage, then the input JSON, and progress if you want a progress bar to see how it worked. Otherwise, nothing would have been displayed here. If you want to convert the GeoJSON to CSV, it would work as follows. You would have an additional command, what's it called? Argument, where you define the geometries as X and Y, stored as X and Y. So you will have another column in the CSV file, which is X and Y. You can also do CSV to GeoJSON, then you would have to add this. Yes. Yes, this is not an error. This is when you have a large file, you will get this message here that the progress won't work. Yeah. And then you can also convert GeoJSON to PostGIS. Then you would have, you need to add the information for the database. So the database name, Postgres, the host, the user, and the password if you have set it. And then you can have a lot of other parameters which you can choose. You can, for example, change the table name with this command. And then you have it in PostGIS. So, as I said before, you can use OGR also with Python. You have various different data drivers. So, as we saw before, you have GeoPackage, you have CSV, you have GeoJSON, and you can use these drivers by specifying the driver code here. So, in this link, you will see a whole list of all the files you can use, and then you can create the driver for this file format, and then you can open this file with this, and then you can do whatever you want with it, and then you have to destroy the source in case you use the script longer. Or you can use the garbage collector, but yeah. For example, if you want to get the layer, this would look like this. You would have the, as we saw before, the source, the data source. Then you can get the layer with get layer. And then you can get some additional information about that layer. So like the number of features here and the extent and a whole other information as well. What I forgot to say that when you use OGR, you have like different, you have a layer, you have a feature, then you have a geometry, and then you have your lat long stored here. And in this case, if we want to see the feature, so we have to get first the layer. We can have multiple layers in the file. Then we can get the feature. We can have multiple features in the file. And then we can get for this feature the geometry. And in the feature you have things like field where you store additional attributes. And here you can get, in this case it was a point, so you can get the x and y coordinates of the point. Yes. So if you want to iterate over all features, you can do this with this. Fairly simple. And if you want to create a file, you have to do a little bit more. So this whole thing, you want to have the coordinates and the title. And in this case, I want to have it as a GeoJSON. You create the driver, as we saw before. You create the layer. You specified the geometry type of the layer. Then you create the feature. From this feature, you want to create a field. And then you add this field to the layer, and then you create the geometry as a point, and then you add the point to the geometry, and then you add then you set the feature, and then you create the feature in the layer, and then you're finally finished. This is the reason for this is because you work with such with so many different formats. And they all have this simple feature standard in there. So you have like the geometry and the attributes, and they all have to obey the system. And that's why you have to always have a layer. You always have to have a layer, a feature, and the field and everything. And that's why it's so complicated. Yes. This was it.